and welcome to my video. Today we'll learn about chapter 10, sound wave. What is sound? Sound is a form of energy caused by vibration of particles. For an example, as we play a guitar, why there's a sound? Because the string on the guitar vibrates, causes the air particles around it to vibrate also. Now we'll learn how sound is transferred. Particles vibrate and collide with each other to transfer sound. Vibrate means move. Collide means hit. Later we will ring the bell and see how sound is transferred from bell to the another end. When the bell rings, we can see that particle 1 and 2, which are closest to the bell, will move and collide with other particles. These red circles are air particles. Sound will be transferred from the bell to the another end by the air. So, when particle 1 and 2 collide with particle 3 and 5, sound is transferred from particle 1 and 2 to particle 3 and 5. Later, particle 3 and 5 will move and collide with particle 6 and 7. So sound is transferred from particle 3 and 5 to particle 6 and 7. And the process continued. Lastly, all the particles will vibrate and collide with each other, so sound from the bell can be heard at the other end. Sound requires medium to propagate. Medium includes liquid, solid, and gas. Propagate means transfer. So sound requires liquid, solid, or gas to be transferred. My question is, why? Before answering the question, let's see this picture. This picture shows outer space, which is vacuum. Vacuum means no air or air particles. If space is vacuum, it means that no particles are present to transfer sound energy in space. So, do you have an answer now? Sound requires medium to propagate because medium such as liquid, gas, and solid has particles. Sound can only be transferred when particles vibrate and collide with each other. Now we will compare the speed of transfer of sound in solid, liquid, and gas. Speed of transfer is the fastest in solids. Sound is transferred very rapidly in solids because particles are arranged very closely in solid. Okay, so this is a guy. He is hammering the nail into the wall. If we enlarge the wall, we can see the particles arranged very closely in the solid. These blue circles are the particles. There is very little space between the particles. Later we will see how sound is transferred from the hammer to the ear of the boy. When hammer knocks on the wall, the particles at one end of the wall vibrate. You can see that the first row of particles start to vibrate when this hammer knocks on the wall. The vibration causes nearby particles to vibrate also. Because the first row of particles vibrate, so next row, which is the second row of particles, will follow to vibrate. And the third row of particles vibrate also. The fourth row and the fifth row. In this process, sound is transferred from the hammer to the other end, so the boy can hear the sound. Sound travels the fastest in solid because vibration from one particle is transferred to the other particle very fast. This is because particles are arranged very closely to each other in solid. Speed of transfer of sound in liquid is slower than solid but faster than in gas. Sound is transferred less rapidly in liquid because particles are arranged loosely compared to the particles in solid. We can see that space between particles is much more larger. So the time taken for vibration from one particle to another particle is much more longer. This is the movement of particles in liquid. Speed of transfer of sound is the slowest in gas. Sound is transferred very slowly in gas because particles are very far apart from each other. The space between particles in gas is the most largest. So the time taken for one particle to collide with other particles to transfer the sound is the longest. This causes longer time for transfer of vibrations. Let's do a quick test. Sound travels faster in solid or in liquid? The answer is solid because particles are arranged closer in solid. Sound travels slower in liquid or in gas? The answer is gas because the particles in gas are much more further apart compared to particles in liquid. Next, we will learn about special characteristic about sound. Sound can be reflected by a surface. Sound can also be absorbed by surface. Then, which surface will reflect sound and which surface will absorb sound? Soft and rough surfaces are good sound absorbers. As an example, carpet and softboard are soft and rough surfaces. Both surfaces can absorb sound very well. While hard and smooth surfaces are good sound reflectors. Marble tiles and wall are hard and smooth surfaces. Both surfaces reflect sound very well. So when you are in a closed room with wall, you shout loudly and you can hear your echo. This is because the wall, which is the hard and smooth surface, will reflect your sound. So you can hear your sound clearly. I believe that most of us have been to the cinema. We can see carpets on the floor and softboards on the wall in cinema. But why is that? The carpet is to prevent echo because the carpet is rough and smooth surface which absorbs sound. This provides better experience for the audience in cinema.